Right, so a system of equations in 3 variables almost has to be elimination, right? Substitution would just take too much time and would get too messy. So the goal is to get rid of the same variable twice. What I'm going to do is I'm going to get rid of z's first. So out of the first and second equations, I can just add straight down. X plus y minus z equals 0, and 2x minus 3y plus z equals 1. If I add straight down, my z's are going to go away. So x plus 2x gives me 3x. Y plus negative 3y is negative 2y. Negative z plus z is zeros out. And 0 plus 1 gives me 1. So there's the first of the 2 equations I need. I'm going to hang on to that and come back to it in a minute. What I need to do now is I need to pick a different pair of equations. I'm going to choose these 2. Now you have to get rid of z's again. Because I got rid of z's the first time, have to get rid of z's again. What I'm going to do on the way down is I'm rewriting this. I'm just going to multiply this row by 2 so that I have 2z and 2z. So I get 4x minus 6y plus 2z is equal to 2. That is this row multiplied by 2. And then this guy is going to stay the same. 2x plus y plus 2z equals 7. Now, in order to get these guys to cancel out, since they're both positive, I need to subtract. That's the only way that I'm going to get 0. So 4x minus 2x is 2x. Negative 6y minus y becomes negative 7y. 2z minus 2z, that's 0. 2 minus 7 is negative 5. So what I can do from here, I have 2 equations now that I can use to eliminate. Now, I'm going to go ahead. It does not matter whether you get rid of x's or y's, but I know that the x's will require less multiplication. If I multiply this by 2 and this by 3, they're both going to become 6x. So if I pull this guy over and multiply by 2, I'm going to get 6x minus 4y is equal to 2. Now, while I pull this guy up, I'm going to go ahead and multiply him by 3. So I get 6x minus 21y, and negative 5 times 3 is negative 15. Now, in order to get these to cancel out, I'm going to need to subtract. 6x minus 6x is 0. That's good. Negative 4y minus negative 21y. So minus the negative is plus. Negative 4 plus 21 is 17y. And 2 minus negative 15, that is 17. Divide everything out by 17, and I get that y equals 1. Which is beautiful, but I need x comma y comma z. So what I can do is I can take this y equals 1, and I can plug it into either of these 2 equations. I'm just going to plug it into this guy in black. 3x minus 2y equals 1. So 3x minus 2 is equal to 1. Add 2 to both sides. 3x is equal to 3. Divide by 3, I get that x is equal to 1. So from here, I have x and I have y. What I need is z. Z is going to come from way up at the beginning. I'm going to choose one of these equations, and I'm going to plug x and y in, and I'm going to be able to find z. So I'm going to use this one, x plus y minus z equals 0. So come on down here. Let me rewrite. X plus y minus z equals 0. But I already know what x and y are. I know that x is 1 plus y is also 1 minus z equals 0. So 1 plus 1 minus z equals 0. So that's 2 minus z equals 0. Subtract 2 from both sides. Negative z is equal to negative 2. Divide out by negative 1, and I get z is equal to 2. So my answer should be a coordinate point, and they go in alphabetical order. So it should go x comma y comma z. So that's going to give me 1, comma, 1, comma, 2.